proportion of digits, okay, students has to memorize a long list of numbers or a long list of digits, and then write the list sometime later. The proportion B of the digits recalled correctly after t hours can be modeled by the function, okay? Now, what we get is mode table function 0.82 minus 0.12 ln x plus 1, yeah? And what we're going to do here is I'm going to start off at 0 hours and at 20 hours, step of 1. Now, do you know what this means? No. Radians only for sine, cosine, tan. Now, anywho, you see the 0.82? 0.82 means if I test you immediately afterwards, you retain 82% of all your knowledge. After 3 hours, it's what? 0.6536. Now, how you get 10 marks for that is you'd say, I'm testing out P3. P3 means your time after 3 hours. 0.12 ln4. But we already got that answer from, so 0.65? No. See that P3? You don't have to write that down at all. What that means is what proportion are you remembering after 3 hours? No, we just sub in the 3 for the time and it gives us the formula. Don't mind that. It's a function basically. So if I said f of x equals 3x plus 1, yeah? And y equals 3x plus 1 is the same thing. What f3 means is what is the output when the input is 3. You went a step too far. You don't divide by the 3. All what you say is that f3 is 10. The output when your input is 3 is 10. That's all we were trying to say. Okay. Now, let's go down. That got you 5 marks. Okay. I know. Now, next one. After how many hours would exactly 55% of the digits be recalled correctly, according to this model? So we're going to write down our original formula, which is what? 0.82 minus ln t plus 1. Give me a second. t.1. Now, does not say we retain 55%. So 0.55. Oh, this is 0.12. Thank you. Actually, I must give this to my 6th year, my 5th year son. So what do you think here? Yeah, bring the 0.82 over and take it away from the 0.55. And give me a sec. So that's minus 0.27, is it? When I take away the 0.82. And then Alan told me that I need to divide it by minus 0.12. Now, what's 0.27 divided by 0.12? Just in the calculator if you can. T. Okay, I'll just change that to capital T. Okay. Now, what's 0.27 divided by 0.12? 2.25? Okay, now, what does ln mean? Log base c. Okay. Now, next part. If I want to free it from the log, what do I need to do? No, it's not a power. It's not a power. No, one of the sides is already logged. Let's figure out what logs mean again. Let's try this out. You ready for this? Lads, how many 2s does it take to make 8 when you multiply them? Give me a sec. When you multiply them, 3. Y'all agree with that? 2 multiplied by 2 multiplied by 2 is 3. Do you remember the movement? 8 equals 8 equals 8 equals 2 to the power of 3. Do you see that movement? Let's do the same movement here. T plus 1 stays where it is in the same way 8 stays where it was. The E, which is in the 2's position, what happens to it? And what happens? 2.25. Then say T equals E to the power 2.25, take away 1. Put that in your calculator and let me know what you think it is. What? Now, do you know what's good about this? Remember that table function we had earlier? I haven't destroyed mine yet. And look, I'm looking for 55%, haven't I? Look what happens. Cross is somewhere between 8 and 9. Do you see that? My answer is somewhere between 8 and 9. So I know we're correct there. I have no doubt in my mind that's full marks. That's 10. It's a difficult 10 as well, isn't it? Yeah. 8.48. Oh, sorry, 48. So 49 rounded off, yeah? 49 rounded off. All right, let's look at the next one then. All right, now what we're going to do here is we're going to differentiate, what's P again? Someone call me out the formula. 0.82, 0.12, T plus 1, all right? Now, when you go to your maths tables and you're going to calculus, which is on page 26 or 27, something like that. 25, yeah? Okay. And you're going down to test your own calculus, okay? Now, what you're going to see here is the derivative of ln x is 1 over x. You see that? Derivative of ln x is 1 over x, okay? Now, I just want to show you a quick usage of this rule for you, all right? So we're just going to get away from this question for a minute. I'm going to set up a new question that has nothing to do with the old question. You ready for this? Here we go. First question. Differentiate ln x. What happens when you differentiate ln x? What's the answer? Great. Next one. What happens when you differentiate ln 3x? 1 over 3x. There's a missing part. Told you to put in your tables. Differentiate what's in the bracket there. 3. And it's actually the same answer. 1 over x. Now, the next one I'm going to ask you to do is this one. ln, for argument's sake, 3x squared plus 5. What do you think the answer is this one? 1 over 3x squared plus 5. Differentiate the bracket. No, differentiate. 6x. You see that? Turns into a fraction, yeah? Now, next thing I'm going to show you, for argument's sake, is if I ask you to differentiate this. All right? If I ask you to differentiate something like this, how would you do that? What's the rule? Okay, so for anybody looking at this at home, I've just gone off the wall here, just explaining this, right? We aren't currently doing the question at the moment. I'm just giving a bit of log differentiation feedback here. So what's u is 3x squared. What's the v dx? What happens when you differentiate ln 2x? 1 over 2x, which is just 1 over x. V is ln 2x, isn't it? And differentiate u. Yeah, and there's your attempt on that. Is that right? Great. Back to the actual question now. Are you good? We're going to differentiate this now. You ready? So we're going to differentiate this. Now, it'll be the p to t means differentiate once. So you can say p dot t because it's in terms of t. What happens when we differentiate 0.82? Gone. What happens if the minus 0.12 stays where it is? Differentiate the log because it's If you differentiate 5x, the 5 stays, the constant goes straight through. If you differentiate 5x cubed, the 5 pops right down, and that turns into 3x squared. The constant at the front always just goes onto the next line straight away. So if I ask you to differentiate, for example, 5 ln 3x, the 5 will just pop in there right away and then be 1 over 3x times 3. And then they'd cancel, wouldn't they? Okay. Now we're going to differentiate this now, yeah? It's going to be 1 over, differentiate that, times 1. And what's our t value? 1. So it's going to be minus 0.12 divided by a half, yeah, times 1, which is going to be minus 6. And that was worth 10 marks. Divided by 2, and then multiplied by 1. P of t is always negative. Do you want to know why it's always negative? Do you notice that it's always going downwards? It never goes upwards. See the way it starts off at 0.82? And see the way it's constantly decreasing? It means your graph is on the way down. As the time goes up, your percentage goes down. It's constantly decreasing. What tells you about the proportion of digits recalled after t hours according to this model? P of t is always negative. The proportion of, it's actually, I just explained it a second ago, the proportion of letters remembered is decreasing as time increases. Yeah. Decreases as time increases. Happy with that? Because it's always going down. Next thing, nearly there. Use the calculus to show that it has no points of inflection. Anybody remember the keyword for a point of inflection? Second derivative equals 0. Yeah. Second derivative equals 0. What was the first derivative again? Just 1 second. First derivative was... no, that's when we put in t equals 1. So it was minus 0.12 divided by 1 over t plus 1. Is that okay with you guys? Now, here's what we're going to do. I'm going to change that into minus 0.12 t plus 1. It wants the second derivative. That's what it wants. That's what we're doing. Second derivative, yeah? How am I going to get the second derivative of this guy? What rule? Quotient rule. Everybody remember the quotient rule? V times the u dx minus u times the v dx all over v squared. Now, this time it's going to be u is minus 0.12. What's the u to t? 0. Doesn't exist. V is t plus 1. What happens when I differentiate t plus 1? 1. Okay, ready for this? Now we're going to do the whole procedure now. V gets replaced with what? Du dx 0 minus u. Another double minus, right? Which makes it a plus dv dx or dv dt 1 all over t plus 1 squared. Now get this. That's going to be 0.1 t plus 1 squared equals 0. And here's the problem. What happens when you cross multiply? What happens to t plus 1 squared? And what you say is no solutions because there's no equation for me to solve. So no point of inflection. Now, if we learn a skill and then don't practice it, how well can we do it? Usually decreases over time. For example, if you learn how to play a guitar and don't play the guitar for a number of months, you'll probably not be as good at the guitar the first time you try it again. Okay, that's brilliant. This effect can be modeled by the following equation. So it's safe to say that this question seems to be very different than the first couple of questions we did. It's almost like a reset. And the first part is worth 10 marks, and the next part is worth 5 marks, okay? Now, where A is the measure of how well a skill can be done at a certain time, t equals 0. B is the measure of how well a skill can be done t months later without practicing. C is a constant. Now, do you know what this all means here? See that blue box? It just means they're numbers. They're real numbers. They're decimals, they could be fractions, they could be whole numbers. It doesn't matter. Now, here's the really tough part. Write C in terms of log 10 base A, log 10 base B, and log 10 base t plus 1. Holy moly. What am I doing? Right. What you know isn't in the equation yet. Do you see any logs yet? So what would be a good idea to do to both sides? Log both sides. Now, have an idea, right? There's two ways of doing this, all right? Here's the first way. Log base 10, log base 10. Give me 1 second. Am I allowed to bring this C to the front? No. I'll explain why. So imagine log 4x squared. I can't bring that to the front because the 2 is not acting on the 4. But it was log 4x 2b squared, then I could bring the 2 to the front. So we're going to separate out using the multiplication rule or addition rule of logs. So what's the addition rule of logs? Plus, see what I'm doing there? That's the addition rule. No, give me a sec. Okay. And then what we're asking for then is log 10 base A. Now, is the C movable now? What's the C movable? Bring the C to the front. C log 10 t plus 1 to the power, gone, yeah? Now, in the meantime, see that log 10 base B? B base 10? I'm going to bring that over here. Okay. I want the C on its own. What's stopping the C from being on its own? It's being multiplied by what? Multiplication turns into division. Is that what you said? Division, right? Huh? Did you say addition? Oh, God. 40 is the pass. Now, E parts. So I'm just going to grab this formula here. I have a feeling I might need it. The whole thing. Okay, Control G and Control D, and I'm just going to copy and paste it. Okay, going to grab that. Huh? This is the hardest question I think we've done today, is it? Huh? Yeah, I think this one's been a step up in standard compared to what we were doing in paper 2. Now, what's it saying? Okay, it's claiming that it's claiming that student got 80% on a guitar exam. After 2 years of not playing the guitar, that's T equals 2. The student got 47 on the same exam. I think that means B equals 47 by the description of the question. And what's A equal to? A is equal to 80. Because if you read the description of the question again, what does it say? A is the measure of how well it can be done when you learned it. B is a measure of how well it can be done T months later. Now, what I didn't specify is, what I didn't like about this question is, it didn't specify if you should use 80 or 0.8, did it? I wouldn't have known in the exam. I'm just looking at the marking scheme and it says use the whole number. I wouldn't have known that, okay, myself. So what all you're going to do is lob in your numbers and you're going to get your C value and you're done. So everybody, get your calculator out. I'm going to do on the bottom, see the bottom? See the T equals 2? That's going to be log 10 base, 3 base 10 on the bottom. What? Oh, the same months. Oh, sorry, excuse me. Wait. What? 2 years. Lads, T is not 2, T is 24 because it's in months, not in years. So it's actually 24 plus 1, which is 25. Can we put all that into the calculator and see what happens? 165, is it? And we're done.